Today we're going to practice constant rate of change. Zach tracks his community service hours for Boy Scouts. Last month, he provided 4.5 hours of service per week. Complete the table below to represent the constant rate of Zach's service hours. So we have the number of weeks, W, which we know that X is always on the left, and total service hours, H, so Y is on the right. So if Zach is going to do 4.5 hours of service per week, then we're going to figure out if he does 0 weeks of service, he will have 0 hours. If he does 1 week of service, he will have 4.5 hours. If he does 2 weeks of service, we can take 4.5 and multiply it by 2. 5 times 2 is 10, carry the 1. 5 times 2 is 10, carry the 1. 2 times 4 is 8, plus 1 is 9. Put your decimal point. So he will have 9 hours. After 3 weeks, if he works 4.5 hours per week for 3 weeks, you multiply by 3, and you will get 3 times 5 is 15, carry the 1. 3 times 4 is 12, plus 1 is 13, with 1 decimal place. So he will have 13.5 hours. And after 4 weeks of service, 4.5 hours per week for 4 weeks, multiplied by 4. 4 times 5 is 20. 4 times 4 is 16, plus 2 is 18. With 1 decimal place, he will have 18 hours of service. Graph the data from the completed table. So we know when we're looking at our table that gives us our ordered pairs. So our first ordered pair is going to be 0, 0. So on our graph, we always start at the origin, and our point will be right here, 0, 0. Our next ordered pair is going to be 1 and 4.5. So we're going to start at 0, 0. We're going to go over 1, and we're going to go to 4.5, which is going to be right here between 4 and 5. Our next ordered pair is going to be 2, 9. Start at 0, 0, go right 2, and go up 9. So that will be right there. Our next ordered pair is going to be 3 and 13.5. Start at 0, 0, go over 3. So that's 9, 10, 11, 12, 13.5. Be right there. And then we'll also have 4 and 18. Start at 0, 0, go over 4. 14, 15. And so 4, 18 would be right there. And then we can draw a line to connect. Arrow on the end. Does the graph show an additive relationship or a multiplicative relationship? When we figure out our K, we're going to be able to write our equation and tell if it is multiplicative or additive. If we find K for each point, K is Y divided by X. 4.5 divided by 1 is 4.5. 9 divided by 2 is 4.5. Remember, I'm finding K, Y divided by X. 13.5 divided by 3 is 4.5, and 18 divided by 4 is 4.5. So K is 4.5. So I can write my equation, Y is equal to 4.5x. So this is showing a multiplicative relationship. Y results from X being multiplied. Y results from X being multiplied. Each week he works for 4.5 hours. He does his community service for 4.5 hours. So when we have our equation in the form of Y equals KX, this is going to be multiplicative. An additive relationship would have something added, which would mean that the graph does not go through 0, 0, so it would not be proportional. So this is not additive, it is multiplicative. Number 3, Write an algebraic equation to represent the constant rate of change as shown in the table in the graph. So we have done that. We wrote y equals 4.5x. Remember to do that. You find k, y divided by x. And in our table, we had weeks, we had w and h. So our table had w and h, which means that w was our x and h was our y. So we can match the letters with the problem and substitute in the h for the y and the w for the x. Number 4. By the end of week 5, Zach recorded a total of 25 service hours. Did Zach's rate remain constant in week 5? Explain your answer. So we're going to have our equation, which is h is equal to 4.5w. And it's telling us that he had worked for 5 weeks, and is it going to be 25 service hours? So we're going to substitute in the number of weeks, which is 5, and then we are going to solve to see, is that going to give us 25 hours? 4.5 times 5. 5 times 5 is 25, carry the 2. 5 times 4 is 20, plus 2 is 22. So we need 1 decimal place in our answer. So we get 22.5. So it is not 25. So no, the constant rate of change does not stay the same. And it says to explain your answer, so you can say no, 4.5 times 5, so this would be his service hours per week times the number of weeks, is not 25. So it is not going to remain a constant rate of change. Number 5. Mason creates figures with square tiles, as shown below. Write a verbal description explaining the relationship between the figure number and the number of square tiles contained in the figure. So I'm going to make a table. So I'm going to have figure, and then I'll have my square tiles. So if I want to connect this to x and y, my figures would be x, and my square tiles would be y. And in figure 1, we can see that we have 2 square tiles. In figure 2, we can see that we have 4 square tiles. In figure 3, we have 6 square tiles. So we want to be able to find k so that we can write an equation. Remember, k is y divided by x. In the first ordered pair, 2 over 1, y divided by x, is 2. In the next ordered pair, 4 divided by 2 is 2. And in the next ordered pair, y divided by x, 6 divided by 3, is 2. So k is 2. So our equation is going to be y equals 2x. And if we want to use the letters here, we can say for figures could be f and square tiles could be s. And so our equation could also look like s equals 2f. So those are the same equations. It's just a matter of whether or not you're going to use x and y for your different variables, or if you're going to label them according to the problem. So a verbal description explaining the relationship between the figure number and the number of square tiles contained is each figure number multiplied by 2 will give you the number of square tiles. Does the equation represent a constant rate of change? The answer is yes, because k is equal to 2. the constant rate of change is 2. Now you are going to complete page 24 by yourself.